Hey, welcome back to the bench. Good to see you again. Hope you're all well. Thanks for joining the channel. Today on the bench I have Harman Kardon PM645. This one is really messed up. It's been sitting here quite a while. I bet you it's probably been 3-4 years now. And I did test drive it and made a laundry list of things it needs. Quite a long list actually. It's pretty messed up amplifier. But yeah, I think this just got pushed aside because I was doing a lot of client units a while back, and this just never saw the bench. But now it's time to get caught up. So yeah, like I said, I did drive this. It's quite messed up. Here's my list. Right channel fades in and out. It's got a lot of pop on power off. And it's got a hum on power on. And I measured some DC on the left channel. It's missing a knob. It's missing a foot. There's 1 foot missing on the back corner there. No power on mute. So when you turn the thing on, it should mute itself for the first 4 or 5 seconds. But that doesn't happen. The sound comes instantly on. And then we got scratchy pots and switches. So quite a bit of stuff going on here. And it's dirty too. It's been sitting. I can't remember if this knob thing, I think I remember buying this piece on eBay a long time ago, and it arrived and the knob was missing, and I contacted the owner and I says, what's going on with the knob? And apparently it must have fell off when they were packing it, so they lost it when they were packing it. But I think in the ad it had the knob, so I think I'm minus 1 knob. Not really a problem. I can go out and steal a knob off my garage receiver. I have a 550 VXI outside in the garage. It has the same knobs. I could steal a knob off of that. See, even this one's loose. The aluminum knobs. Can glue those back on. The PM645, they made a couple versions. They made this one here, which is just the plain, and then they made the VXI, which has the window here, and it has the high power, high voltage, high current, and then the 2 LEDs. So this is just the normal 645, not the VXI model. Let's give it a quick test now to find out if there's anything to add to the list, and we'll check the DC on the back and see how bad it is. Okay, that's power switch is off. Let's plug this thing in. Polarized plug. Polarized outlets. Okay, switching it on. Heard a little grunt from the transformer. Jumped up to 20 watts. And I think the speaker switch is already on. -14 millivolts on that side. -24 millivolts on this side. I don't know where we got our DC measurement from. It might change as it warms up. Looks like it's reasonable. Drawing 29 watts and it's climbing up quite quickly. Don't like that at all. It's really heating up fast. I'm going to turn this thing off. Maybe we've got a problem with the amplifiers. Shouldn't climb in power like that. Alright, here we go. Dust the old lid off. Let's see. Got a bit of a heat scorch back here in the back. And looks like they have some pads here, rubber pads that are kind of corrosive. So that's weird. Inside we got cooked boards. Look how cooked they are. These boards are black. Oh dear. Got a transistor flopping in the wind here. It's a voltage regulator transistor. 2 transistors flopping in the wind. Look at that. I wonder why this thing didn't work very good. This cap's bulged. Bet you a lot of these caps are dead too. So yeah, that's not cool. I guess. That's not the way it should be. And the power amplifiers look cooked as well, as boards are quite dark in these areas. There's a lot of heat. Okay. Other than that, everything looks good. We've got phono over here on this side. Quite an evolved phono stage too. Looks like they revised it. The earlier versions were about half this size, and looks like they revised the phono stage, and hopefully for improvement. Although they don't have any shielding here, this is kind of not what I like to see. It'd be nice to have some shielding here on this little stretch to keep the noise down. They probably thought it wasn't a problem, so they left it alone. And then we have all of our input and output connectors from the back travel through these long wires up to the front switching, which also isn't really a great idea because you're getting a lot of pickup of stray noises and stuff here. But this is kept away from the power supply section on the other side, so the transformer. Hopefully we don't get a lot of hum and other noise pickup here. Volume control. There's our switches, our rotary switches on this board, push button switches on this board. And then underneath everything, we can't see, is our tone boards under there. So this is all power supply on this side, amplifier on this side. Yeah, and it's a heavy little unit too, so it's got maybe some power behind it. The transformer's got some beef. I think the spec on this is 40 watts a channel, so got a little beefy there on the iron. Not too bad. Let's flip it over and pull the bottom off. All right, pulling the bottom off. Some nice dust. Looks like somebody's been in here before me. Their fingerprints. Yeah, these transistors are completely disconnected. Somebody tacked in a resistor here. I don't know what that's all about. And we got massive cracks in all of the driver circuitry and stuff for the amplifier, so this thing's pretty much a basket case in its current condition. Here's a look at the transistors. There's one of them. Here's the other one. Looks like it's hard to say. The pads might be still okay. I saw one pad here broken somewhere. I should maybe discharge these big caps before I go any further. Let's see what we got for voltage on these big caps. Ooh, what happened here? Got a bent end. Straighten it out without breaking it. Alright. 3 volts, or 0.3 volts there. 0.4 volts, so we're okay. And here's this resistor flopping in the wind. I don't know what purpose this serves. What is that, like a 20 ohm resistor? I don't know what somebody was doing there. I don't know if you can see this. We got cracks on these transistor leads here. Cracked on the center one. And then on the other side, same thing. Cracks here on all these. Some of these are cracked as well. So, yeah, surprised it didn't grenade itself. And we also got cracks here. This is the treble pot, and I can see cracks on the treble pot. Balance pot looks okay, but the bass pot is under here, and you can't see it. But I suspect it's cracked as well. So it's all got to be scrutinized and resoldered. Alright, so that's a lot to take in there. There's quite a bit going on in the boards itself, just with cracked solders and broken joints. We also have scratchy pots and switches. So I'm just going to disassemble all this, remove the front. These boards are going to come out. This board is going to come out. They're going to get serviced. I'll remove the volume pot as well. Everything's going to come out, including the heatsink. I'll remove the heatsink from the board for cleaning. I can clean everything underneath. All these green TK caps will be garbage. They're going to go. And then we have Masashita caps on the phono stage. Everything's going. So I'll start on this. It's not as modular as I like to see, but it'll still be nice to work on. I think it's not layer upon layer of boards that are buried. It's actually should be pretty easy to work on. It's pretty well laid out, and looks like it's friendly to service. So I'll get started replacing caps and doing my usual, like all these switches here. We might have to replace these switches if they're really bad. These switches, remember testing them, they were quite problematic. So if they don't clean up, they're going to get replaced. And then I'll bring you back in when there's something to talk about. So the heatsink compound on this is pretty much dried up. It's all crusty and flaky. So this all has to be cleaned off and repasted. And now I got the heatsink out, I can clean that. You can see it looks pretty burnt under here. Looks like it's seen a lot of heat. I don't know if you can tell. Or is that just dust? I think it's black soot or something. But that's unusual that it would get under the heatsink like that. So I'll have to give this a good clean. I wonder if these caps probably need replacing too. 8,000 microfarad at 45 volts. Yank those out and test them. So wherever they have this black foam, it's all petrified now. It's hard as a rock. This black foam, you can see how the corrosion, see that corrosion in here? That's all from that foam. And this foam here also on the top, this is what corroded the lid. So I don't know what kind of a foam they were using to be so corrosive. Definitely not something you want to use long term. Look at what it did to the steel. Just turn it to rust. Now I'm looking at this. This is something that experience tells me. Feeling these caps, they feel like they're empty. And they feel like they have no weight to them. Like they're... So I'll bet you they are dead. Let's measure these. These are 8,000 microfarad, 45 volts. Okay, Masashita caps. Let's see what my tester says. Now I haven't tested these, so bear with me here. Okay, here's the first one. We're down at 6,400 microfarad from 8,000. Yeah, I'd say that cap is shot. Next one. Make sure I short it out first. This one's even a little. We're 6,200 microfarad down from 8,000. Yeah, those two will get replaced. Definitely dried out, and it's from that being parked in that heat zone there at the back near those power supplies. So we got a heat problem in the back. Maybe we should add some extra heat sinking or something to keep it cool. But if it's cooking all the caps around it, it probably needs some help. I'm finding a lot of cracked solders on these input connectors. This is the tuner. That one's broken, that connection there. And I think, well, even on this phono input, there's a crack on this one. This one's nearing cracking. So this all has to be taken out and resoldered. All of these. RCA connectors are notorious for cracking when they connect to a printed circuit board, because every time you plug in and remove, you flex that, you stress that little connection there and it cracks. Alright, right out of the gate we're seeing problems here. This is a phono stage amplifier. Let me zoom in, maybe we can see some nastiness here. Every single one of these caps is leaking. These are Masashita caps. You can see the ooze coming out that one. Same with that one. Look at these ones. Same thing. Always leaks out the negative side, it seems. This one here. All 6 of these caps are leaking. Mashishitas anyway. These 330 Mashishitas are not, which is kind of odd. But we do have some board damage here. I can show you board damage right here. This is what happens when the electrolyte leaks down the leg and it comes in contact with the copper. It starts to corrode. Where else do we got more? Oh, look at this one. This one's really bad. And it seems to go after the solder as well, so that one needs to be repaired. And I think there's another one here I saw. There's 2. There's this one here is not capacitor related. That might be it for this board. Oh no, right here. Right here. There's another spot. You can see the copper's compromised. So typically what I do when I replace, this is a cap here, yeah, that's for sure. When I replace these caps, these two caps are in series. And what they're doing is they're using a polarized cap in series with each other to make one bipolar capacitor. So I remove, anytime I see this, I remove both these caps and replace it with one bipolar. And sometimes I adjust the value, but these are 2 10s in series, so that would equate to 5 microfarads by the time it's all said and done. So what I might do is I might just replace this cap with a 10 microfarad bipolar, and you can see the way it's wired here. They are wired in series, right? This is the caps connected together. So anyways, what I was saying is when I replace the caps, remove the old cap, and then you got 2 holes. Put the new cap through. I'll solder this one down to the pad, and this one here, what I'll do is I'll take the lead and I'll fold it down and I'll bridge it over to this pad, and I'll solder both of them. That way, if this copper in the future decides to disintegrate further, this will never go open circuit. You'll always have that wire there that's backing it up. So that's what my point was. So I'll get started on this. Got lots of work to do. See, this one here, I'll have to lay the wire down and maybe make a connection to this pad here. Just because this does not look good at all. It's ready. It might even be completely eaten through. Wow, I didn't think this thing was such a basket case, but it is. And, well, it is what it is. But I'm just about done the recap. And I gotta say, this is no exaggeration. Probably 90% of the caps are failed. I'm not just saying bad, failed, which means they're no longer doing their job. And I remember testing this thing, and it did work, but it wasn't working very good. So yeah, I'm just about done the capping, and then I'm going to move after some transistors in this area. These are all baked transistors in the power amplifiers. I'm going to go after those next. I found a bad transistor in the power supply, and it had very low HFE. So I'm going after semiconductors in this thing, because it's so baked. It's seen so many hours of cooking. I didn't realize it was this bad. And I did go back in my records and check where I got this 5 years ago, and I probably paid too much for it. But whatever, we'll make it good. We'll make it sing, and we'll find it a new home. I have a feeling this one's going to be a nice sounding amplifier. It's got some nice features in the design of the the power supplies and in the amplifiers themselves. It's got this bass contour circuit, which is kind of unique. It's got a little transistor amplified circuit there for the bass contour. I don't know, seems a little overboard, but we'll see how it goes. So yeah, I'm just about done. Did the pots, still have to do switches, and then finish this contour board, and then transistors, and then I'm gonna be putting things back together, and we're gonna start testing. So I'm working on the power amplifiers right now, and I found something really kind of interesting. They're running their drivers. They have 2 transistors in parallel for their drivers. Bases are connected together, Collectors are connected together, emitters are collected together. So they're actually piggybacking one transistor on top of another here. And these transistors aren't the greatest power handling. They're 2SD667 and 2SB647. They're generally used as drivers, but I don't think they're used in this manner in such a, well, this is a 40 watt per channel amplifier, and these drivers are a little light duty. So is that why they're paralleling these two transistors together to beef up current and power handling capability? That's what my guess is. Let me know what you think below. I'm thinking of pulling these four out and replacing with two beefier drivers that can do the business without having to parallel them up. See, right now I'm pulling them out and they have different HFEs. Everything's baked and everything's mismatched now. So that's why I'm thinking maybe just get rid of that and just put in a single transistor. Put in a transistor that I can attach a heatsink to and something keep it cool. Like I said, let me know what you think. Never seen that before in drivers where they double them up like that. I know they do it for the output devices, but then they also have provisions, like each set of transistors will have its own emitter resistors. Just going through and checking contact resistance on these four switches. It's pretty horrendous. I'm getting like 10 ohms on some of these. So I'm going to remove these four switch bank on the switch bank here, these four, and I'm going to treat them and clean them properly, put them back, and then I'll probably end up doing this switch as well. This switch here is, let's see if I can get it out. This one here, probably end up doing these two switches as well, just to make sure there's no chance for any upset. Alright, I think I'm at the point where I could plug it in and do my initial power up. Let's do that right now. I was going to fly or fry. Let's see. Down to 45, down to 13. Amplifier should come on. Here you go. Bumped up a little bit. 19. Seems to be hovering around 19.3 watts. And we don't have any zero adjustments for our channels. Let's check our voltage on our outputs. That's going well. I think we're good. All right, what do we got on this channel? Why is it? Turn the volume down. It's jumping all over the place. You see it jumping around? I don't know what that's about, so we might... Okay, here's the other channel. It's jumping around too. Let's check our bias. You get 3 millivolt bias on that one, which is nothing. This one here has 4 millivolts. Okay, so let me set up and we'll adjust the bias and then we'll see. Alright, so the spec is for leave the thing running for 20 minutes to stabilize, and then 33 millivolts across both emitter resistors. So let's turn this thing on again. And when the power comes on, this will rise, and it is. And we are very low. So let's try adjusting this. 33 millivolts. Wow. Okay, I'm going to let this thing sit for a while before I get too carried away. I'm going to turn this down to about 20. And we'll leave it there. And then we'll just turn up the other one, because this is going to heat up the heatsink quite a bit. And things will change and drift. So let's do the other channel. We're already at 8.6. Okay, let's turn this one up a bit. Also put this one at 20, and our consumption's already jumped to about 30 watts. Now I'll let this sit for about 20 minutes, and then I'll come back and my target's going to be 33, maybe a little bit lower, 30. and we'll get this thing dialed in. Okay, so it's kind of settled around 28 millivolts for both channels. I'm just going to leave it there for now because I know from experience that when I start test driving this and put it on the listening bench, that bias current tends to creep up and I have to go back in and turn it back down again. So it's good there now. I'm going to leave it alone, and I think we're ready to do some testing. Alright, I think I'm ready to do a power test here, so let's get things rolling. Turn the power on. And I believe it's already set up. Oh, there we go. Okay. Let's see what this thing can do. Okay, there's our clipping. Back it off a bit. It's got a soft clip to it. Right about here. I'm going to say right there. That's maximum. And we have 20.35 volts RMS. Start our timer, and then I'll bring you back in 10 minutes. Sooner if anything happens. Here's our power consumption, 183 watts. Okay, I think we're at the 10-minute mark or close to it. Testing some things here. Rectifier diodes are up over 80 degrees Celsius. They're cooking. This heatsink, though, I can't get a measurement on because it's aluminum, but I'll guarantee you it is over 60 degrees right now because I have a hard time touching it. So let's shut this down. Did okay, didn't blow up, which is surprising. Now let's turn down the volume, and then let's look at some square waves. Here's our square wave. That's 1,000 hertz, and that's approximately 1 watt. So we have bass cut. Wow, there's a lot of great channels, really. The pot is not very good on that right channel. Okay, so that's bass boost. So yeah, a little bit off 12 o'clock and we get this on the right channel. So that pot is definitely not 100%. Okay, treble cut. Controls turned out nice and clean. Or maybe I'm speaking too soon. That was treble boost, treble cut, balance. Oh, there we go. Need to work it some more. Balance. This is our stereo reverse switch. Has no effect. This is our tape monitor. Okay, we got some buttons up here. This is our bass contour. So it does boost the signal a bit. Subsonic. Barely noticeable at 1,000 hertz. High cut at 1,000 hertz. And the last one is our tape copy. Okay, so there is no loudness. They have the bass contour. Okay, let's go down in frequency. Start at 100 hertz. And it looks just as good as the 1,000 hertz. Okay, so bass cut, bass boost, our contour. Wow. What is going on there? Okay. It's quite the bass boost circuit. This is our subsonic Okay, it has more effect at 100 hertz. Okay, let's keep going. 40, 30, 20, 10. 10 hertz. It's looking good at 10 hertz. Just checking to see if we have any dirty switches, and they seem like they're all 100%. I cleaned them, they're all good. Okay, so that's 10 hertz. Let's go down and see how low this can roll. 9, 8, 7, 6, 5, 4, 3, 2. It's 2 hertz. Kind of wonky looking. How come we get spikes when I turn down the bass? That's not cool. Alright, let's go to the high end. 1000 hertz. 10 kilohertz. Looking pretty good. 20 kilohertz. And we lose it right around here. 44 kilohertz. It's actually doing a really good job. Yeah, I like it. Alright, so here's the parts I pulled out. Normally I go through the capacitors and I tell you, oh, this number of caps are bad. When I was going through the recapping, I was thinking to myself, well, at the end I'm going to have to summarize these caps. What am I going to say? Am I going to say, oh, this one's good and this one's good and the rest are garbage? That's what I was thinking. But now, when I finished, I see all these caps here. Not one of these caps are serviceable. They've all failed. Every single one of them are baked. And a lot of these blue mesh sheetas, well, they're all leaking. I could pull any one of these caps out of this pile and test it for you and show you that it's no longer anywhere near its value and no longer doing its job. So all the caps are gone completely. I've never seen it this bad of an amplifier with all the caps toast. But here we are. So these ones were replaced. I replaced the 8 driver transistors with 4 larger, upsized, to keep down. I didn't understand why they did this. This was generating a lot of heat on the board, and I got bigger transistors in. I mounted them higher up off the board so they have a chance to keep cool and keep the board cool. These 2 transistors here are woefully undersized, so they added an aluminum heatsink, but these are just TO92s in a little tiny transistor, and these are the regulators for the power supplies. Power supplies for the phono stage, the bass contour circuit, and I believe for some of the tone circuits too. So they're drawing a lot of current on these and dropping a lot of voltage across them, and they were getting hot too. So I got those out. This resistor, I don't know what was going on there. Somebody put it in. But that's it for parts. Quite a few. All the caps are bad. Never seen that before. So there it is, it's done. The PM645. I really like this black anodized aluminum. It really looks sexy, and it's got the black lid too. It looks really good. I like this. And I think this is what the black plastic crap was trying to copy, was this look here. But you can't copy aluminum. in plastic. It just doesn't work. And I did steal a knob off the 550 VXI. Which one is it? This one here. It's not the same as the other one. The other one's aluminum. This is just plastic, but they look identical, so I'm happy with that as well. So this is all ready to go. I'm gonna bench test this one for a few weeks. A lot of damage inside from heat. It was totally cooked. Everything inside was baked. Even the boards. Had to be very careful working on these boards because any force on the pads and they'll lift off the board. So I'm glad this one's done. I'm gonna put this aside and put it in the queue for listening, and then probably find it a new home. So all right, well, thanks for watching. Take care, and we'll see you on the next one.